Welcome. We're going to look at our last section, our last thing together for this class, and we're going to do a semester 2 cumulative review. Just know the notes and this review we're doing in the video here does not cover chapter 10. Since we just did 10 last week and all of last week's DI was a chapter 10 review, I didn't include it here just for the sake of redundancy. However, if you do want to review that, go ahead and watch last week's DI or look at those review assignments. You do have chapter 10 review in your homework in the semester 2 cumulative review. There are some chapter 10 questions. I just didn't include them here since we have so recently hit that. So just to clarify, we do have chapters 5, 6, 7, 8 included in this review. Remember, we did not do 10 this year. If you see a problem and you want to know more about it, you want to review it more, you can't figure out where it comes from, just shoot me a quick email. I'll be happy to let you know which section of notes you should kind of focus on there. All right, let's go ahead and dive in. We've got a picture here, and we're told that points E, D, and H are the midpoints of our sides of the triangle. And we know some lengths here. UV is 40, TV is 48, and HD is 40. We want to find the length of TU. So there's kind of a lot going on here, and let's just quickly review what a what these midpoints are creating here. These midpoints are creating what we call the mid-segments of the triangle. And a mid-segment is going to be half as long as the side it's parallel to. So if I'm looking for side TU here, I'm looking for this side here in orange. So in order to find that length, I need to find the mid-segment, and whatever the length of that mid-segment is going to be half the length of TU. Well, I'm told here that HD is 40. So I know HD is 40. So to find that length of the missing side, I'm going to take 40 and multiply it by 2. So TU has a length of 80 units long. Our next one, we're looking at a picture here. We want to find the length of, or the value of Z. So Z is just part of the expression to represent the side lengths of JM and MK. So notice here that point M is perpendicular to my segment JQ, and it's also point B, which is my midpoint. So we know any point that's on the perpendicular bisector of a segment is going to be equidistant from the endpoints, meaning JM is going to be the same length as MK. Knowing that those two segments are congruent, we can go ahead and take those expressions and set them equal to each other. 12Z minus 18, and set that equal to 3Z. Since my two segments are congruent, their lengths have to be equal. I'm going to start by subtracting 12Z from both sides. Don't lose that negative. 18. 3Z minus 12Z is negative 9Z. Divide both sides by negative 9. Be careful with your negatives. Negative divided by negative is positive. 18 divided by 9 is 2. So Z is equal to 2. So the beginning of this semester had a lot of theorems, a lot of things that are true, these little kind of nuances we need to remember. So definitely spend some time reviewing your notes from those chapters to remember things like any point on perpendicular bisector is equidistant from the endpoints. All right, we also spent a lot of time talking about centers of triangles in the semester. Now, I am not going to require that you remember or review which types of centers are which and that you identify them. You may need to know certain things about centers. For example, our next one looks at centroids, but I'm not going to require that you can identify the difference between them. That was a pretty tough chapter, and we're going to go ahead and move on past that. So here we're given a triangle, DEF, and we're told that C is a centroid. So just as a refresher, that centroid, it's kind of like your center of gravity, and it's where the medians intersect. Now within the centroid, or within this picture here, we're told that DM, this whole length here, is 30 units long. We want to find DC and CM. DC is from the vertex to the centroid, and CM is from the centroid to the opposite side. So we need to remember something that's true about centroids here. From the vertex to the center, so DC, vertex to the center, is going to be 2/3 of that full length. So 2/3 the length of DM. And now DC is 2/3. That means that CM is the remaining 1/3 of that full length DM. If you can remember that, 2/3 and 1/3, the rest is just going to be a plug and chug. DC, I don't know, that's what I'm solving for, is equal to 2/3 times the length of DM is 30. We're given that. 2/3 times 30 is 20. So DC has a length of 20 units. Same thing here for CM. Go ahead and substitute in 30 for DM. And 1/3 times 30 is 10. So Two things you can do to double check here: make sure your math is right, and make sure that your two segments DC and CM have a sum of 30. 20 plus 10 does in fact have a sum of 30, so we're good to go. So just spend a little bit of time kind of reviewing what we know about those points, but you don't have to be able to identify them. And just as a reminder, we talked about this before, but anything that's on the test will come off of your review homework. So if it's not on the homework review assignment, don't worry about it. It won't be on your test. All right, moving on. This was in our next chapter. We talked a lot about the measures of interior and exterior angles of regular polygons. Just as a refresher, a regular polygon means all the sides are the same length and all the angles are the same length. So here we're asked to find the measures of an interior angle and an exterior angle of a regular 20gon. So a couple of things we need to know here. Remember this formula that said the sum of all of the angles. So if we add up all the angles of a regular polygon inside, those would be the interior angles. So the sum of the interior angles is equal to n minus 2. Remember, n refers to the number of sides we have, times 180. So let's find that first, and then we'll work on that to figure out what just one of those angles would be that they're asking for here. So the sum for this 20gon is going to be 20 minus 2, since I'm told it's a 20gon, n is 20, times 180. 20 minus 2, make sure you're doing that in your calculator first, or well, hopefully maybe in your head. 20 minus 2 is 18. 18 times 180 is 3,240. So that means in this 20-sided polygon, all of the angles inside that polygon are going to add up to 3,240 degrees. But I'm not asked for the sum. I want to find the measure of just one angle. So to find one angle, we're going to take that sum, 3,240, and since there's a total of 20 angles, since there's a total of 20 sides, we're going to divide this by n, or divide by 20. And 3,240 divided by 20 gives us 162. That means if I have a polygon that's a 20-sided polygon, and it's regular, so all the sides are the same length, all of the angles are equal, each angle inside that polygon is going to be 162 degrees. That's going to be a big polygon. Now the other question it asks for here is we want to find one of the measures of an exterior angle. As a refresher, in any size polygon, it doesn't matter how many sides I have, the exterior angles are always going to have a sum of 360 degrees. Does not matter how many angles I have, how many sides I have, the angle sum of the exterior angles is going to be 360. So I know they all add up to 360. I want to know what one of them is. So just like we did over here in orange, we're going to take that sum of 360 and divide by 20. 360 divided by 20 is 18 degrees. So my exterior angles are going to be very small. My interior angles are going to be very, very large. As a refresher, an interior angle plus an exterior angle forms a linear pair, so they should have a sum of 180. 162 plus 18, we're good to go. Next, we spent a lot of time in Chapter 6 classifying polygons, deciding if something is or is not a parallelogram, deciding if it's a rectangle, a rhombus, or a square, and so on. Spend some time reviewing those facts. Remember at the very end of Chapter 6, we made a big chart of all of our review and everything we had learned in Chapter 6 about what's true. We did a chart where we filled in definitions and pictures, and we also did a check mark chart for the properties of those. So spend some time reviewing that. Have that handy for your test. So I'm looking here, and I want to know if this quadrilateral pictured at the right is a parallelogram based on the given information. So remember, a parallelogram, by definition, has two pairs of parallel sides. But we know a lot of other things are true about it as well. So spend some time refreshing that. And we know things like if we have one side both parallel and congruent, then it's a parallelogram. If we have two pairs of congruent sides, then it's a parallelogram. But notice here, all we know is that I've got one pair of congruent sides. The top and bottom are congruent. That alone does not meet any of the criteria for a parallelogram. So in this case, no. We cannot say that this is a parallelogram. Now, if it had been marked like this, where we have one pair of sides congruent and parallel, then we could classify this as a parallelogram. But we just know they're congruent, so we need to stop there. If you need help on any of that, shoot me an email. I'd be happy to kind of dive into that a little bit deeper. All right, the next, we've got a picture of an isosceles trapezoid. Remember, an isosceles trapezoid is a trapezoid that has its legs congruent, or its non-bases are congruent. And only in isosceles trapezoids, we know that the base angles are congruent to one another. So that means that this angle here has to be congruent to this angle. And if my angles are congruent, my measures are equal. So 71 must equal 3x plus 20. And solve for x. Subtract 20 from both sides. So 51 is equal to 3x. Finish it off by dividing both sides by 3. And x is equal to 17. So again, just a refresher on knowing all of those things that are true about our polygons. Then we moved on to similarity. And we talked about similarity in more than just triangles, but we kind of focused on triangles. And we had these certain similarity shortcuts. Make sure you spend some time reviewing those. Here I'm given two triangles. I know the side lengths on two sides of each of the triangles, and I know one angle. Well, if you remember, we do have a similarity shortcut that says if I have side angle side, proportional, and angle congruent from one triangle to the next, then my triangles are similar. Well, notice I do have side angle side here. Side, angle, side, angle, side. I need to check, though, before I say with certainty that my triangles are congruent, that my sides are proportional, or my sides have that similar ratio. So I'm going to start by listing the small side of my left triangle over the short side of my right triangle. So 9 over 15, and reduce. Each can be divided by 3, so 3 over 5. So that means that if I'm looking at this shorter leg of those two triangles, there's a ratio there of 3 to 5. We need to check if the longer leg also has that same ratio. So since I picked the left triangle to be on top for the first one, I need to be consistent. 12 over 20, and each can be divided by 4, end up with 3 over 5. Since that ratio is the same from the smaller side to the larger side, I can now say that my triangles are congruent by side angle side similarity postulate. Now remember, when we list our triangles congruent, make sure you do so in corresponding parts order. So I'm going to say yes, triangle GUA is similar to triangle EFB, and we're going to say by side angle side. So spend some time reviewing and refreshing what other similarity postulates we came up with in that section. And then we went on to talk a lot about right triangles and the Pythagorean theorem. So make sure that you review that Pythagorean theorem. I don't have an example here, but that you can work it to find the hypotenuse as well as finding one of the legs. And you'll have some problems like that in your homework. This one asks us to take these sides of a triangle and decide if we have an acute, a right, or an obtuse triangle. And to do that, we're going to kind of set it up like the Pythagorean theorem. We're going to take the two smaller sides, label them A and B. The longest side is side C. And then we're going to compare some lengths. So let's start by labeling A, B, and C. So I've got side lengths 6, 5, and 7. My shortest side length is 5. I'm going to call that A. My next shortest is 6. I'm going to call that B. And C is 7. Now, you can flip around A and B. You could call A 6 and B 5. That would be fine. Just make sure that they're your two smallest. What's most important is that C is your longest side. Now I'm going to go ahead and find what A squared plus B squared is equal to, and that's going to help me determine what type of triangle I have. So 5 squared plus 6 squared is 25 plus 36, which gives us 61. Okay, I'm going to put that aside. Now I'm going to figure out what C squared is equal to. C squared is 7 squared is 49. Notice here, 61 is greater than 49, meaning A squared plus B squared is greater than C squared. Now we had a little table in our notes. If you need to refresh that to remember which is which, if A squared plus B squared is greater than C squared, that means our triangle is acute. All angles are less than 90 degrees. If A squared plus B squared equals C squared, we have a right triangle. And if A squared plus B squared is less than C squared, we have an obtuse triangle. Now, on top of talking about Pythagorean theorem to find side lengths in a right triangle, we also looked at what we called special right triangles, meaning if I'm given certain circumstances, I can find the side lengths without knowing two of the sides. So without necessarily knowing everything I need for the Pythagorean theorem. And those special right triangles were 45, 45, 90, and 30, 60, 90. We've been reviewing 30, 60, 90 with chapter 10 as we look at area of regular polygons. So I put a 45, 45, 90 in your notes. You'll see both show up in your homework assignment. And I'm not even going to look at what I know in my picture yet, other than the fact that I have a 45, 45, 90 triangle. And I'm going to write down the rule that I know, and there's only one for 45, 45, 90, and that tells us that the hypotenuse is equal to the square root of 2 times the leg. Now, since it's a 45, 45, 90, that means that it's an isosceles triangle. So each of these two legs are going to be the same. They're going to be 4. I don't want to know the leg, though. I want to know the hypotenuse. That's my variable x. So I'm going to replace x with the hypotenuse, square root of 2, and my leg is 4. My last step here is I'm just going to rearrange that to be x equals 4 times the square root of 2. It's just good practice. We typically like to write that integer value ahead of the square root. Although it's right either way, just make sure that you end the square root and you're not putting the 4 underneath the radical. So make sure that you are also reviewing your 30, 60, 90 triangle rules if you haven't had a refresher with Chapter 10. Then we spent a big chunk of time in Chapter 8 looking at right triangles and what we call trigonometry or SOHCAHTOA. And remember, SOHCAHTOA only works on right triangles. So we have things like law of sines and law of cosines that we use when we don't have a right triangle. But if we look here, I'm looking for side A or BC, however you want to label it. And notice I do have a right triangle. So the fact that I'm looking for a side, I know an angle on another side, that's my cue that I'm going to need to use SOHCAHTOA. So I'm just going to go ahead and write it down at the top of this problem. And that's something I recommend you do at the top of your page when you're working on your problems. Now I'm going to look at my picture and grab my highlighter. I'm going to start by looking at the angle I know. That's angle A, that's 31 degrees. And I'm going to highlight that angle. The reason I highlight it is because it makes it very clear which side is my opposite side, and that's where I like to start. The side I did not highlight is the side that does not touch that angle. That's my opposite side. And that's what I'm looking for. So I know I'm going to need to pick one of my trig functions that uses opposite. Now I need to look at what else I know. I know that C here is equal to 17 meters. And C is across from the right angle, so it's my hypotenuse. So I'm looking for the opposite side, and I know the hypotenuse. Now I need to determine which trig function I'm going to use. Does sine, cosine, or tangent use opposite and hypotenuse? That would be sine. Sine is equal to the opposite over hypotenuse. And so we set that up by saying sine of my angle, which is 31 degrees, equals the opposite, that's my variable A, over the length of my hypotenuse, which is 17. And cross multiply to solve. A times 1 is just A, is equal to 17 times sine of 31. Make sure that you have a calculator that can do that. I don't want you missing problems on your semester test because you don't know how to use your calculator or get it from degrees to radians, or you don't have one that has a trig function. There are lots of options out there. You can use the one on your calculator or on your computer. You can Google scientific calculator. Most smartphones have this capability. Just make sure you practice with it before you go into that test. Don't take this semester test with a brand new calculator because you are more likely to make mistakes here. And when we do 17 times sine of 31, we get an A value of about 8.8 meters. And that's just straight plugging into my calculator. Now I've got one more SOHCAHTOA one I want to look at, and this one works it a little bit different. I'm still going to start before I even look at it by writing down SOHCAHTOA at the top. Then I'm going to grab my highlighter and highlight the angle I either know where I'm looking for. In this case, notice I know two side lengths. I know a 4 and a 5. I want to figure out what this angle is, x. So since I'm looking for that angle, that's the angle I'm going to highlight. And once I have it highlighted, I'm going to label my opposite, is the side I did not highlight. And I'm going to label this other side here that has the 4, since I know the length of that side. Now, this is not the hypotenuse. Hypotenuse is going to be my longest side across from that right angle, making this my adjacent side. So I know the opposite and the adjacent. Now I need to pick which trig function I'm going to use. Notice tangent is the only one that uses both opposite and adjacent. And this one's going to look a little bit different since I don't know that angle. My expression is going to say tangent of x, since that's what I'm looking for, equals opposite, which is 5, over adjacent, which is 4. Now, I get a lot of times students wanting to, quote, divide by tangent to solve. Well, we can't just divide by tangent. Tangent itself isn't a number. Tangent's a function that we can do to a number, but it isn't a number itself. So we can't divide by it. We have to use what's called the inverse trig functions to get x by itself. So we're going to say x is equal to inverse tangent of 5 over 4. Again, make sure you have a calculator that can do this. Make sure you're comfortable with that. When you plug it in, you should get a solution of about 51.3 degrees. If you're not getting that, if you're plugging everything in right and you're not getting that, check to make sure that somewhere on your calculator it doesn't say RAD or it doesn't say radians. We want it to say degrees. If you don't know how to change that, ask. Definitely ask before you hit that semester test. Whatever you use on the review for a calculator, make sure you're also using on the test. I hate to see errors just because of our calculators. All right, in our very last one, we're going to look at this review again. Remember, we're not hitting Chapter 10 in the video just since we just had it, but there is some in your homework. And notice here it's telling us we need to use law of sines, but we just talked about this, but it's a good refresher that the reason we have to use law of sines here and not SOHCAHTOA is because this triangle, ABC, is not a right triangle. Remember, SOHCAHTOA only works on right triangles. So in place of SOHCAHTOA, when we don't have a right triangle, we have what's called law of sines. And before I even look at my picture, I'm going to go ahead and write that down. And remember, the important thing here is that our letters match up. We're always taking sine of an angle, and our uppercase letters always represent angles, and we're always dividing it by the opposite side. Those lowercase letters represent side lengths. So I'm asked to actually find both sides B and C here. So the first thing I'm going to do is I want to find this angle. This angle is missing, and I can find it using triangle sum. So to find the measure of angle B, I'm going to take 180 and subtract my other two angles here, 79 and 43, and that tells me that angle B is equal to 58 degrees. That's just going to give me a good basis to start, since I do need to find both side lengths there. Now my next step is going to be to locate one angle and a side opposite it that I know the measures of both. Okay, so I need to know the angle measure, and I need to know the length of the side that's across from it. I need to figure out which angle I have that for. If I look here at angle A, I know it's 43 degrees. If I locate the side opposite it, or what we call lowercase a, I know it's 5 units long. That's the only side I know the length of, so that's where I'm going to start. And I'm going to write sine of my angle, which is 43, divided by the side opposite it, 5. And that's this first part here of my formula. Now, in order to solve something, I need to set it equal. And you can do this in either order, whether you want to start with B next or C. I'm going to go ahead and solve for B. And I'm going to say sine of angle B, which we just found to be 58 degrees, over the side opposite it, which has a length of, we don't know, variable B. That's what we're going to solve for. Once you've got that set up, cross multiply. We get B times sine of 43 is equal to 5 times sine of 58. So now to get B by itself, here we can divide. The difference here than the last one is that I do have a number with that sine of 43. It's not sine of B, in which case we'd use inverse sine. In this case, it's B times sine of 43. Sine of 43 is just a number. So I'm going to divide both sides by sine of 43. And that's something that you should be able to put in your calculator. 5 times sine of 58 divided by sine of 43. Depending on the calculator you use, you may have to close a parenthesis here after the 58. That's a common mistake that I see, is if your calculator automatically opens a parenthesis, especially if you have like a handheld calculator, make sure you close that parenthesis before you put your divide by sine of 43. And if you do that and you get the correctly in your calculator, you should get B equal to about 6.2. Again, if you're not getting that, let me know ASAP and I will help you with that. And our last one here is we do want to find C as well. So I'm going to still start the same way I started the last one. Sine of 43 over 5, the angle I know and the side opposite it. And set that equal to sine, I'm looking for side length C, so I need to use angle C, which is 79, over lowercase c. And again, we're going to cross multiply to solve. So I get C times sine of 43 is equal to 5 times sine of 79. And the last step, divide both sides by sine of 43. Again, that's just some number. My variable is not inside the sign, so that's a legal move. So in my calculator, I need to do 5 times sine of 79, close that parenthesis if you have parentheses there, divided by sine of 43, and you should get 7.2. If you're using the calculator on your computer, you may have to do that a little bit more step by step. I would just suggest that you give yourself about 4 decimal places if you're rounding throughout instead of doing it all at once, so you can get your most accurate answer. So that's your review on sections 5 through 8. There are a few questions from chapter 10. If you need review on that, let me know. We are not meeting for a live DI in the last week of class. This is in place of that. It is not worth credit. I'm not requiring it, but I would suggest that you do it. If you have any questions, let me know. Otherwise, good luck.